Greetings and welcome. I'm Mr. Bowden. Glad to meet you on the video here. And I put these videos, I'm going to put a series of 4 videos together for you to support your summer homework for AP Calc BC next year. And there's a problem set for the summer homework, and there's the expectation that you set up your composition book and add a few sections to it. So I decided this year to go ahead and record some videos, do a little bit of a lesson for each of the concepts that I'm having you add to your summer composition book. Mainly they're ones that sometimes we want to add a little more detail to make sure people are proficient with, so everyone's starting in the same page, whether you're coming from AP pre-calculus or you're coming from AB or you're coming from another school or what have you, that everyone is in the same place. So I've got a series of videos that I'll put together for you, and we'll go from there. I'll call these out somehow on the summer homework packet and link them up on my YouTube channel. Please like and share and subscribe there. That's what they always say. So the first one I'm going to do today is a little bit of, I just noticed this book sitting here. It says 5-place mathematic tables, and across the top says saves time in solving math problems. So I was going to show you one thing today in this first video where we can save some time in solving math problems, and then the other piece is a bit of algebra with rational expressions. We just finished rational expressions in my algebra class, and so this is an extension of that where you're taking rational expressions that have been combined and you're taking them apart. So we'll be looking at partial fraction decomposition and solving systems as a way of solving our partial fractions problems. So with that said, it is a pleasure to hang out with you, and let's do some math as we do. So I'm going to switch this around. Look at that document camera. Oops, upside down. Look at that switch. Good deal. And let's jump in here. So the first point I wanted to make in our discussion here is with polynomials. And so for polynomials, if I'm being like super nice and I'm setting up an algebra problem and I want to have some solutions that are accessible and I want a degree 3 polynomial, I can set this up, and this is kind of what's going on in the background when I'm making these problems. And we got x squared, and we got minus 1x, and we've got a minus 2, and then we got to do that distribution. I probably go over here on a little rectangle to think about that distribution, so I don't have to worry about that double distribution across the trinomial, which is a bit of a hassle. And instead, I can go over here on a rectangle and work it out easily. This is plus 3x, and that's plus 6. So apparently, my cubic here is 2x cubed minus 5x squared. Take away x plus 6. And then we will hide this behind the curtain. You didn't see that. And so in our algebra class, this is something we need to solve. And it's got 4 terms, and it fails factor by grouping, and we're sad about that. So then we need to find one of the roots. And if we have one of the roots, then we can divide it out and start to work our way down to the quadratic, etc. Finding that root, rational root theorem, and we've got to look at plus and minus ratios of the factors of the constant term versus the coefficient of the x cubed term. And nobody enjoys that, except, well, I do, but aside from me, and maybe 1 or 2 of you, of course, then we usually just go to our calculator anyway, graph it, look for a real intercept. So if we were to graph this, we would see that it has an x-intercept at 2. Then we know that x minus 2 is a factor. divide out the x minus 2, we get this quadratic, which is obviously factorable, and we get our 3 solutions. So we either had some tedious algebra or we had to go ahead and use the calculator. So let's go ahead and use the calculator right out of the gate. But instead of going that algebraic approach and using the graph to find that root, I'm going to go to the apps. So we've got this app here. So the app button is right there next to math apps. And we're going to go down here to PLYSMLT 2, PLYSMLT 2. So right now we're talking about the PLY part of PLYSMLT. Okay, planned ahead. And so PLYSMLT is the polynomial root finder simultaneous equation solver. We're curious now about finding the roots of our polynomial. We have a degree 3, so you hit order 3. I put it on having complex numbers as an option. And so then we hit next. And then you just feed in your polynomial. So what do we have here? We have 2x cubed minus 5 minus 1x plus 6, solve, and our answers are 2, 3/2, and -1, which up here we could see clearly that those were the answers we were headed towards. So that's cool, and there's much applause. That was excellent. PLYSMLT, good job, buddy. And really, I want PLYSMLT to be a tool that we have available, because as we get into calculus, this isn't going to be where our equations are going to be generated. They're going to be equations that represent the acceleration or velocity of a particle in motion or something else that's being modeled, and we're not assured that it's been set up as a nice, easy problem that's going to have nice rational solutions. So we will run into things where we're not sure where we're headed, and the solutions, none of them are likely to be pretty. So maybe it's 3x to the 4th plus 2x cubed minus 7x squared plus 4x minus 12 that we need to find the zeros of. And so that's definitely question mark, guys. And so we can go to PLYSMLT, type that in, and find the roots. Okay. So there's a little advertisement there for PLYSMLT, at least the poly half of PLYSMLT. Okay. Well, that's not our main topic today, so I won't belabor that one. Instead, let's jump into the partial fraction idea. Okay. So partial fraction decomposition is the idea that, I guess I should write that down at least once. There we go. There we go. A little highlight color here. What do we got? Not bad. Okay, so partial fraction decompositions, our task is to go from, say, for instance, 8x minus 1 over x squared minus 3x minus 28. And we want to see if that expression, that rational expression, can be split up. So in this form, it's not as useful to us as if it was taken apart. So one of the keys to being able to do partial fraction decomposition is that the bottom factors. So if it doesn't factor, it's not going to be able to be decomposed. So we need to be able to factor that. Hopefully that's the right factoring. And I think I'll start the rest of my problems here. I'm not going to bother. You should be able to factor. So our goal is to break this into something over x plus 4 plus something over x take away 7. So if we can find those a and b values, this is going to be a format that's going to be a lot easier to work with in our problem. So the algebra of this is that first we're going to flatten this out. So we're going to multiply both sides of our equation here by x plus 4x minus 7. So these two binomials. So when I multiply the left-hand side by that, I of course just get 8x, take away 1 all by itself. The right-hand side, when I hit the first term, the x plus 4's cancel, and I get an ax minus 7. And the second term, the x minus 7's cancels. I get a bx plus 4 like that. Fine. And we need to solve for a and b. So we're going to clean this up a little bit. 8x minus 1 is ax, take away 7a plus bx plus 4b. And that means that 8x take away 1 equals the x's. I have a plus b x's, and my constant is negative 7a plus 4b. And the idea here, and this is kind of an interesting little piece of algebra, is that I've just got this one statement, but I've got two actually nice pieces of information. I know that 8, coefficient of x, is the same as a plus b, and I also know that negative 1 is the same as negative 7a plus 4b. So I actually do have two statements here. I could say that a plus b is 8, and that negative 7a plus 4b is negative 1. So there I have a 2-by-2 system of equations. I got two true statements relating a and b, and now I can solve. So depending on your inclination, you could solve this by substitution, elimination, solve it by Kramer's rule, you could solve it using matrices. But since I was doing my advertisement here for PLYSMLT, we look at the SMLT part of PLYSMLT, it is the simultaneous equation solver. So let's look what PLYSMLT says about this one. Go to number 2. Got two equations, two unknowns. Hit next. So I pretend the x is a and the y is b. So I have 1, 1, 8, negative 7, 4, negative 1. Solve. There we go. So a is 3 and b is 5. Equals 3 and b equals 5. And that's pretty cool. So our expanded form here or our decomposed form, I should say, this is a 3, this is a 5, and now we've taken our rational expression where the bottom did factor, broke it up into two fractions that are both simpler to work with. And we did that by equating the coefficient of x and the and the constant. So a little bit of practice with that. We become proficient there. If we can solve, if we've got the calculator available, the simultaneous equation solver is a nice tool for that. So with partial fractions, there's a couple other levels of complexity to them other than the basic one there where we've got nice roots like that. Like these could get a little bigger. Like say for instance, I had a one that looked like 9x squared minus 25x minus 50 over x plus 1, x minus 7, x plus 2. That's a little bit more. But since they're just nice little linear solutions down there and there's no repeated ones, we're just going to be headed towards a over x plus 1 plus b over x minus 7 plus c over x plus 2. So other than there being a little more fussiness to the algebra, it's going to be the similar process. Multiply both sides by these 3. 1 cancels each time. So you'll have a multiplied by a quadratic, b against a quadratic, c against a quadratic, clean everything up, equate your coefficients and solve for your three unknowns. Okay, so they can get bigger in that dimension. I'm going to skip past that and jump into the other two versions. So the other two things we can have going on. So I guess that was like version 1, the cool ones. Version 2, we could have unfactorable. With an A. Unfactorable quadratics. So say, for instance, 7x squared minus 4x over x squared plus 1x minus 2. So here I've got this quadratic bottom right here. And so quadratic bottom, that's an issue, is it didn't factor nicely. And so what that one's going to need, the phrase I use for myself to remember this is quadratic bottom gets a linear hat. So his hat is going to be ax plus b. That's going to go over the quadratic, and then the other one just gets a nice little c over the top. So this is the linear hat. So in order to decompose a partial fraction decomposition where we've got a unfactorable quadratic down there, we need a linear piece on the top. And so then to work this out, we're going to multiply through by the bottom. And so we've got 7x squared minus 4x equals ax plus b against the x minus 2, c against the x squared plus 1. So we're going to work our way to a 3 by 3 system with the a, the b. So we get ax squared minus 2ax plus bx minus 2b plus cx squared plus c. And then we need to clean it up. Where are my x squareds? I have a plus cx squareds. Where are my x's? I have negative 2a plus b x's. And where's my constants? I have opposite of 2b plus c is my constant. I hope those. Let's double check. It's no fun when you get things wrong. That's good. That's good, and that's good. Okay, we're cool. So equating our coefficients, we have a plus, there's no b here, so it's 1a plus 0 b's plus 1c is 7. Negative 2a's plus 1b plus 0 c's is negative 4. And 0 a's minus 2 b's plus 1 c is 0 for the constant. So getting your grid together here, and then we can head back to our friend PLYSMLT and go to a 3 by 3 system and hit next and just load it in. 1, 0, 1, 7, negative 2, 1, 0, negative 4, 0, opposite of 2, 1, 0, solve. There we go, 3, 2, 4. 3, 2, 4. So it must have been 3x plus 2, and that's a 4. And then we have it split up. Okay. So quadratic bottoms get a linear hat is probably the more complicated one. There's one more with repeated linear, and at the tail end here, I'll just show you the setup on that. Is repeats, repeats go twice, I guess is the way to say it. So if you have x squared minus 4x plus 18, over x plus 4x minus 1 quantity squared. You're going to have a over x plus 4, b over x minus 1, and the repeat here gets a c plus dx up top. Actually, the dx isn't, yeah, that's not needed. Because it's repeated linear, the d will be 0. So if you've got a repeat here, you just tack it on one more time. So a over x minus 4, b over x minus 1, c over x minus 1, quantity squared. And then we're back in the same game again. Multiply out, set the coefficients equal. So it's a nice little piece of algebra. We run into it just a bit, but that's kind of the goal of the summer comp book, is to make sure we're all on the same page with these skills. And depending on which class you had last year, partial fractions may or may not have been something that you got to play around with. So this is what summer comp book is all about, not pre-teaching any of the calculus, but just making sure that we all have the same foundation in our algebra to be successful next year, as we will be. Well, cool. Well, I thank you for hanging out with me here on the video, and I hope you enjoyed meeting PLYSMLT, and I will see you on the next one.